SAT Test 9, non-calculated section, question number 14. You're given a system of linear inequalities and you are asked to pick which of the graphs and shaded region represents the solution to the system of inequalities. In Algebra 1, we learned how to solve system of inequalities by graphing them and shading them with different colors. When the colors overlap, that provides us the region with our solutions. However, this is the non-calculator section and you have a minute and 15-20 seconds at most. At this point, my advice is to pick a point with definite coordinates from each region. And if you could pick a point with positive or 0 coordinates for ease of calculations. So for point A, here I'm picking point O with coordinate 0 because this is part of the shaded region of option A. So that means when x is 0, y is 0, and that point would satisfy both inequalities. So let's see if it satisfies the first one. So I'm plugging in 0, 0. If y is 0, x is 0. What do I get here? 0 is greater than or equal to positive 2. That is not a true statement, so A cannot be my answer. And I'm moving on to the next shaded region. The region that satisfies both inequality is going to be my solution. B, I'm going to pick, there's no way for me to pick a positive x coordinate. I'm going to pick negative 3, 1. Negative 3, 1. 1, 2, 3, 1. So, oops. When y is 1, x is negative 3, what do I get for the first one? 1 is greater than or equal to negative 1. That is a true statement. For the second inequality, I get 2 times negative 3. This is going to be negative 6 plus 3 is less than or equal to 6. That comes down to negative 3 is less than or equal to 6. That is a true statement. B satisfies both inequalities, and I'm not even going to check C and D for time-saving purposes. But just to prove that this method works, I am going to continue and making sure that no point from any other shaded region would work for my two inequalities. So from C, I'm going to pick, let's say, this point over here. It has coordinates 0 and 3. When x is 0, y is 3. 3 and 0. So I get 3 is greater than or equal to 2. That stands. And then I have 2 times 0 plus 3 times 3 is less than or equal to 6, which comes down to 9 is less than or equal to 6, and it's not a true statement. So C satisfies the first inequality but doesn't satisfy the second. From D, again, I'm going to proceed with the same logical steps. I'm going to pick a point from D and try it out. So I'm going to get that point. That point has coordinates 2, 2. So when x is 2, y is 2, and let's see if they work. 2, 2. I have 2 is greater than or equal to 4 from the first inequality. It does not work, and B stays the answer.